It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to solve problems on continuity. A manufacturer of closed rectangular containers having a square base maintains its surface area at 40 square inches. If the base has a side x, express the volume of the container in terms of x. Identify the domain of the resulting function and show that it is continuous in its domain. So our problem here is telling us that we have a closed rectangular container with a base which are square. So since that is square, we expect that if this is the base here, this one is equal to this one. Although on the picture there, it might not look like it, but they are equal on measurement. Now, according to that one, if the base is side x, so since that's a square base, we have here an x, and of course this one is also an x. So that means that the height there is our y. Now, according to this one as well, we have the surface area, which is 40 square inches. So again, surface area represented by SA is equal to 40 square inches. And once we say surface area, we're actually getting the areas of all the faces there of our container, which is rectangular with the square base. So we will be getting the area of each. Now, our basis is a square, so of course we are expecting that we will have there a side square. Since the sides there has measure, which is an x, or expressed as x, so we have it as x and then square, because area of a square is simply square of its side. Now, there are two squares here, the bottom and at the top, so we will be multiplying this by 2 because we're simply adding all the surface area or the areas of our face x. And then this one here, which is a rectangular, will be adding also the area of each. So for this one, we have our length as y, our width as x. Area of rectangle is width times length. So we have that one as x times y. And there are 4 faces that are rectangle. We have this 1, 2, on the side here at 3. At the back, we have that one as 4. So we will be multiplying this by 4. And this is our equation for the surface area. Now, plugging in the surface area, we have that one as 40 equal to 2x squared plus 4xy. And then, based on the problem, we are to express our volume of the container in terms of an x. So, we are going to recall finding the volume or the formula, and since this one is a function, we will be representing that one as v of x because this is a function in terms of x. This will be equal to volume of a rectangular container is simply length times width times height. In this aspect here, we have our length, our width, and our height. So we have that one as x times a y. So simplifying that one, that is x squared times a y. And we have that as our function. Now, since we wanted to express our volume in terms of x, so we will no longer be seeing a y here. So going back to the surface area, we have our y there. So we will be solving y in terms of x. So noticing 40 to x squared for xy, we've got common factor which is 2, so we're dividing that one, or getting rid of the common factor by dividing each of the term by 2. 40 divided by 2, that's 20. That's equal to 2x squared divided by 2, that's an x squared, plus 4xy divided by 2, that's a 2xy. Now, we're not yet done. We're solving for the y, so we move x squared to the other side by simply subtracting that one with x squared. and so with the other side. So we are now with 20 minus x squared. That will be equal to a 2xy. Now we're not yet done. We need to get this 2x out from the picture on that side because we need to look for y. We divide this by 2x, and so with this one by 2x. This will be canceled out. So we are now down to our 20 minus x squared over 2x. That's equal to y. So utilizing this one, we are going to replace our y here on the volume function. We have v of x that will be equal to x squared. Replacing our y here, we have 20 minus x squared over 2x. And then we let our v of x be equal to 0 since we wanted to solve for the values of x, in which that will serve as our domain or the interval of our domain that are gonna be accepted as part of the values of your x. So plugging in, v of x here will become a 0. That will be equal to x squared times 20 minus x squared over 2x. And since we can simplify this one here, we can take out an x here, and so with this one, so we are down with a 0 equal to an x times 20 minus x squared over a 2. So that one. Now this time we are equating each of the factors to 0. So we have one factor is x, that will be equal to 0. The other factor is 20 minus x squared over 2. That will be equal to 0. This one, we can simply multiply this by 2 to get that 2 out from the picture on the left side. So multiplying that 1 by 2, that means we're canceling this one and that one. So we have 20 minus x squared equal to a 0. So out from there, we can now move our x squared to the other side by simply adding an x squared here, and so with the other side. So this will be now 20 equal to an x squared. So since that's a square, we are going to get rid of the square by doing the square root of that one. And this will be now our x, which is square root of 20. Although you may have the idea that it could be a positive negative square root of 20 as a result. But then again, since we're talking about volume here, volume measurement, we cannot have a negative value on the volume. So that is why we are only taking the principal root here. Principal root meaning the positive root of our 20. So we have that one. So our interval now will be from 0 up to 20, meaning these are the domain of our function. Our x values can only take in between numbers from 0 to 20. We cannot take a 0, nor we cannot take a 20 here because it will make our volume a 0. Now, checking, because according to this one, we need to show that it is continuous on its domain. If you try to recall on checking whether that's continuous on an open interval, we have to simply check the values in between the two numbers on the open interval there, checking if there is a problem when it comes to the function. But upon looking at that one, the function is polynomial itself. And once you've got a polynomial there, we don't have really a problem. We cannot meet a break. We cannot meet a hole in there, nor anything that is problematic. So that is why this one is continuous on that interval. So again, our function, the v of x here, is continuous under the interval 0, 20. So this is your teacher Jenny saying, practice and practice, and that will make you somehow perfect one day.